Today, Doug is joining a team of scientists who want to predict how icebergs behave. The team want to gather data on the shape of an iceberg, information that will help predict its trajectory out to sea. The scientists are using specially designed remote sensors to scan icebergs from every direction.
It's a complicated jigsaw. It's a little bit, you could think of it as a crime scene where you have the forensic people go in and they pick up little bits of clues and together you make a bigger picture.
Aerial mapping and sonar robots are still in their test phase, so there's no substitute for first-hand observation. Particularly underwater, where the shape of the iceberg becomes just a shadow.
It's hard to piece together what we're seeing above water with underwater without your imagery, so that's what this is going to be really helpful for.
I'll actually get a picture of what the thing actually looks like, so they can hopefully tell more about how accurate their sonar picture is compared to the real thing. It's quite eerie going down the side of the iceberg. You're going down into the darkness, into the blue, into the green. And very occasionally there'll be this really loud thump, just like someone had hit you with the flat of their hand in the centre of your chest.
Being this close gives Doug an unrivaled view of the shape that's hidden beneath the waves. Thanks to the electromagnetic force that holds frozen water molecules together, ice floats, but only just. 7/8 of an iceberg is beneath the surface. The part underwater is called the keel. It catches the ocean's currents and affects the speed and direction the iceberg will travel. Up this close, Doug has discovered the keel of the berg is riddled with even more intricate shapes.
So while I'm swimming along the iceberg, I'm very aware of the dimpled shapes. It's like a giant golf ball on one side of me. And I'm just hoping that all these sort of observations from me myself and the fact that I'm putting them down on film, I'm hoping that that will be useful for the scientists.
How was that?
How was it? It was cold. It's a little bit murky. And I'll tell you all about it when I get on the boat.
The irregular and hidden shape of iceberg keels means predicting their trajectory is still an immense challenge. These human towers give us a glimpse into what it takes to defy gravity. At the base, each team member is positioned so the bodies spread the weight above them as evenly as possible. To diffuse the force of gravity acting on them. That produces strong, simple shapes. The strongest is the circle. It's symmetrical, equal in all directions. No other shape distributes the weight of the tower more evenly. No other gives the tower such strength. But no matter how strong these shapes are, gravity is unforgiving. That's a worry if it's your child climbing to the very top.
Quan la Carla i la Mariona pugen a dalt al castell, jo haig de seguir el castell de baix fins a dalt. Hi ha mares i pares que potser no em puc estar sense mirar el castell.
Vilafranca are attempting to build the highest, most complex tower of the day to win the competition. And Carla, being so light, must climb to the very top. The power of Earth's gravity means the weight bearing down on David is hard to endure. If one person falters, the entire tower could buckle and Carla will plunge to the bottom.
Si ells cauen, és la derrota més màxima, no? El més fràgil són els nens, no vols mai que caiguin, no? Vols fer el castell, però a més vols que no es facin mal, aquesta pressió sempre hi és, no?
They've done it. The Castellers from Vilafranca are the champions. The team's skill and the shape of their tower has defied gravity. While the Rivieros flee the pororoca, Serginho Laus is eager for its arrival.
A pororoca mudou minha vida. A onda perfeita, num lugar totalmente inusitado. Uma energia muito grande, e uma força e um volume de água que é monstruoso.
Serginho seeks out the pororoca whenever he can.
A diferença de surfar no rio e no mar é que no mar a gente surfa ondas de segundos e no rio a gente surfa ondas de minutos ou horas.
The pororoca once carried Serginho to a world record, surfing the wave for some 10 kilometers.
Quando eu tô na pororoca, eu acho que eu tô surfando em outro planeta.
Surviving the pororoca this long means taking on the full power of the wave, dodging all the debris ripped up by the force of the water.
Bom, quando a pororoca tá vindo com força máxima, eu poderia dizer que tá vindo uma cavalaria ou tá vindo uma locomotiva desgovernada vindo em sua direção. As pessoas falam que eu sou maluco. Surfar na Amazônia, no meio da selva, com a água tão intensa, mas eu sou apaixonado por tudo isso daqui.
The pororoca is an extreme example of tides that rise and fall across the planet each day. Tides are a constant reminder of the endless dance of the Earth and Moon through space. The team has only explored part of this cave system, and seen a hint of its beauty. What they will find in the morning will be truly spectacular.
All right, so we're going to tie in the main line and swim down. And about 10-15 minutes in, the line makes a slight turn to the left. Also there, I expect it to be pretty bad viz. We have to keep pretty close to the line and be aware of that at all times.
The next day, the visibility is cleared. The explorers are about to get their first glimpse of a rare natural phenomenon created by water's power to dissolve.
I don't know what it is. I can't tell you exactly what's happening, but something different, something very, very important is going on in this cave.
The quality of the water suddenly changes. This strange and beautiful phenomenon is known as a halocline.
You pop up and there's crystal clear water, and it almost is as if you're lifting off and flying in the air.
Seawater drawn in from the ocean is dense with dissolved salts and minerals, and sits in a discrete layer beneath the fresh cave water.
And it's so clear, there's a tendency you want to take your regulator out of your mouth and you want to start breathing the water.
All this is created by the marriage of hydrogen and oxygen. Water's power as a solvent means it transports Earth's ingredients around the planet. And it does the same within us. The elements carried around the planet are also carried around our bodies. Every living creature on Earth needs water to deliver the ingredients of life to its cells. And life will go to extraordinary lengths to get those ingredients. The squid are proving elusive. But on the beach, there are the first signs that the firefly squid have arrived. This is the display that everyone has been waiting for. This remarkable light show is caused by a beautifully controlled chemical reaction inside the squid. A chemical called luciferin reacts with oxygen and produces light.
Oh, good call.
The luciferin is simply made of elements, such as carbon, nitrogen, and sulfur. The basic elements and reactions of the Earth's raw ingredients have been hijacked by the squid and then controlled in an exquisite expression of life's alchemy. Back on board Mr. Urakame's fishing boat, there's a change in fortune.
まあ、小太郎はいるからいいんだけど。寝るよ。網網網網。の、おいよ。大きいのでドッと取ってくればいいんだけど、やっぱりそれだけいいものをウーチャラとしてはプライドとして出したい。ライト。おお、全部。おお。前。It's beautiful.
Although uniquely spectacular, the squid are doing what all life does. Controlling chemistry to do what it needs to survive. Ultimately, life is a cascade of controlled chemical reactions between the elements of Earth. Reactions played out at exactly the right time, in exactly the right order. Reactions that harness energy and sometimes beautifully release it. For Mr. Urakami and his crew, this is the spectacle they live for. Life's chemistry in action. Of all the colors of the rainbow, one in particular glows back out into space. The iconic blue of our planet's oceans. A color caused by the unique way that light interacts with water. There are few better places to see why water is blue than this crevasse in Iceland. This is Þingvellir, a rent in the Earth caused by the planet's tectonic plates drifting apart. In places, the rift has, over time, become flooded. Professional diver Ted Wignall has been exploring this site for years.
The water's clear because it's been filtering for a very long time through the lava, the rock that we have here in Iceland. It comes from Langjökull, Iceland's second largest glacier. When you first descend, you almost lose your sense of distance. You think that you're shallow, you're actually very deep because you can just see for so far through the water.
The purity of the water not only increases visibility, it also provides the perfect environment to understand why water is blue. When the sun's light hits the water, photons get absorbed. But not all at the same rate. Red photons get absorbed by the water first. The reason is down to the structure of water molecules themselves. A water molecule is made of one oxygen and two hydrogen atoms. When the light streams into the water, the red photons happen to have just the right energy to make the bonds between the atoms vibrate. And so the light energy of the red photons is absorbed. As Ted dives deeper, the energy of more red photons is soaked up in the vibration of the water molecules.
As you descend, you see that the first colour to drop off is red. So my beautiful bright red suit here, very quickly as we descend, the colour begins to fade away.
Orange, yellow, and green photons don't have the perfect amount of energy to make water bonds vibrate. But eventually, even they will be absorbed.
What happens is the red ebbs out and we're left with a sort of rusty colour.
At this depth, only blue photons have survived their passage through the water. And that's why water looks blue.
We need to get ready to go, don't we? Push!
For 8 years, the Nation family have been consumed by an obsession.
73, 98, 97, 69, 98, 100.
They've left their home on the southeast coast of England to live in the cold climes of northern Norway, spending their weekends chasing the planet's most extraordinary and colourful phenomenon. The Northern Lights, or the Aurora Borealis.
It's an addiction. It's an absolute full-blown addiction. It's a buzz and it's a rush of adrenaline and it's a holding of your breath and wow.
The Aurora Borealis is a light show like no other.
Let's see if I can find a corona. Okay, this is a corona. You get this purple or pink in the centre, then the green comes out of the purple, and then the white part that you can see is where it almost overexposes, and that's the part that tends to move very quick. Our eldest, Aurora, she's 11. She's fascinated by why do those different gases make those different colours. Oshi, she likes the pink because she likes pink, it's her favourite colour. And Lyrica is quite a fact box on everything. She can explain to you what causes an aurora, where it comes from, the technical names, and what the magnetic field does and how it stops the solar wind from harming us.
The aurora's ethereal colours are created when energetic particles from the sun interact with the Earth's upper atmosphere. When they strike gas atoms, the energy makes those atoms vibrate, and photons of light are released to dance across the dark night sky. However, the aurora can be elusive. To see it from Earth, conditions have to be just right.
Part of the fun is succeeding against the odds. And we've gone out in weather like this, and then it's suddenly cleared, and then the skies have suddenly opened up.
Shall we go and build a snowman?
To give themselves the best chance, the family pick a spot and set up camp under the stars.
That is not a bad fire, is it? That's on the flame. Mum, are you going to burn it?
Careful, Louis. Don't lean too far forward.
I think that's enough.
They wait,
Will you hold it just
sometimes
there?
for
That's the best
hours.
place to hold your sausage. That's the hottest part.
Is it? How?
It wasn't a Bunsen burner.
The chances of seeing the Aurora Borealis are greater up here within the Arctic Circle, because the charged particles streaming out from the sun are drawn towards the magnetic North Pole.
Oh. I can see some uprights there.
There we go, look at it.
Beautiful. Look at it. Look how bright that is up there, look. Yeah! Yes! Now that's what I'm talking about. Look. Ooh. Look. Corona! Look at it. Stunning.
Wow. Oh!
It's so much better.
And on the left, look, there's some pinks at
Yeah,
the bottom.
it's gonna do Corona. Look.
But the aurora isn't simply beautiful. The colors are a code to the physical world because they reveal the chemistry of our skies. Each chemical element is unique, and each one gives off photons of a particular color. The green comes from oxygen atoms, purple from nitrogen. The light shimmering across the sky reveals the oxygen and nitrogen-rich atmosphere that envelops our planet. This kind of colored light doesn't only tell us about our world, it has also shown us the universe.